The Earth has four major layers, divided by composition and density. Starting from the layer humans live on, we have the crust. It is made of hard, brittle rock with elements that are of light density. This layer is very thin with an average thickness of 7 to 8 miles. The next layer beneath is the mantle. This layer is about 1,700 miles thick, making it the thickest layer in the Earth. Most of the mantle is fluid as it is under intense heat and pressure. The next layer down is the outer core. This layer is about 1,300 miles thick and is completely made of molten rock and metal. The final layer is the inner core, which is about 800 miles thick. Though temperature should be hot enough to melt the inner core, it is a solid ball of nickel and iron due to the intense pressure preventing it to liquefy. A major discovery in the 1960s proved once and for all that continents move. People could hardly believe that the Earth's surface was broken into many different plates. When scientists uncovered the process of sea floor spreading, coupled with seismic data, we then knew the interior of the Earth was much more dynamic than originally thought. Seafloor spreading showed that new material was being added from volcanic activity along mid-ocean ridges. The addition of new material moved the large lithospheric plates, which accounts for the drifting of continents first proposed in the early 1900s. This movement is primarily caused by the transfer of heat within the part of the mantle called the asthenosphere. Convection currents within the asthenosphere constantly rub against the lithosphere like a conveyor belt. The lithosphere reluctantly moves as a result. There are three major plate boundary types that account for much of the surface features we see. So when plates move, we can see the consequences of that movement on the surface that we live on. The first one is the divergent boundary. These were first discovered in the Atlantic Ocean when attempting to lay down the transatlantic cable in the late 1800s. It was later confirmed with sonar in 1925. Divergent boundaries in the ocean create mid-ocean ridges where new material from beneath the crust wedges up and pushes the existing rock out of the way. On land, we see rift valleys that can create gorgeous views as the land separates. Convergent boundaries do the opposite of divergent ones. These boundaries come crashing together and are known for tall mountain building and strong earthquake activity. Convergent boundaries, where two continents run into each other, can create long and tall mountain chains, much like the Himalayan mountains. The crust bunches up because the crust has nowhere to go. When a continental crust runs into an oceanic crust, the more dense ocean crust will slip underneath the continent in a process known as subduction. These subduction zones will create tall mountains as the convergent forces will bunch up the rock into a large pile. Volcanoes also form here as water mixing with the rock can lower the melting point of the rock as it goes deeper into the hot mantle. These pockets of less dense molten rock will try to force its way up through the crust. As the ocean plate goes underneath, it will melt into the mantle and become recycled. When two ocean crusts converge, the more dense of the two will subduct underneath, but the mountains created are not visible from the ocean's surface. The final plate boundary is the transform boundary. This boundary has two plates that grind past one another laterally. Apart from seeing strike-slip faults, the most notable feature of this boundary are the earthquakes generated from time to time.